liquids and gases, this picture will help us to understand it in much better way. Okay. In solids, each molecule, atom are very well arranged and they are having a very strong attractive force between each molecules and they are perfectly shaped. In case of liquids, the liquid molecules are not very well arranged, but there is a cohesive forces between different molecules and they try to stick together as much as possible. But in case of gases, it is completely different. Each molecule is free to move and they are having a very weak cohesive forces between the molecules. And we are going to learn about the concept called pressure, which is nothing but the average force exerted by the molecules on the walls of the container. We will see about this in next slides. So in summary, we can say that a liquid is a substance with a definite volume, and volume varies slightly with pressure and temperature. Whenever the pressure or temperature changes, there will be a variation in the volume because it will expand. And most of the liquids can be treated as incompressible, and in most of the applications it is true, and in some applications it may not be true. Whenever we apply our knowledge of fluid dynamics, we should be careful about understanding when we can consider the flow as an incompressible flow or when we can consider it as a compressible flow. And liquid forms the free surface under the action of the gravitational force. And as far as gas is concerned, possesses no definite volume and expands till it gets the shape of the container. And most of the times gases are compressible, and in some special cases we can treat gas as incompressible. I will tell you two examples. You should be able to distinguish where gases can be considered compressible and where gases can be considered incompressible. Suppose we have a ceiling fan. When we switch on the button, it will begin to rotate and air will begin to move. So in this particular, air is the fluid which is flowing. So shall we consider the flow of air in this case as compressible or incompressible? This is first one. Second one, let us take IC engine in which the working fluid is gas, and we can say work is done by the gas on the piston. So in this case, what should we consider? Is it a compressible flow or incompressible? Yeah, give a thought on this one and reply back to us on this case. And there is a very important concept called ideal fluid. When we make idealization, this idealization is done to understand what is the best we can have. And everything is compared with respect to that. So in fluids, what is the ideal fluid? The ideal fluid is a one which has no viscosity, no surface tension, and is incompressible. And there are some cases where we can treat even the real fluid as the ideal fluid and get a very good engineering insight, and we can solve those kinds of problems. We will understand this and also where we can apply in future slides. Fluid flow analysis can be studied either theoretically or experimentally. Whenever fluid begins to flow over a simple geometries like a flat plate or a simple circular duct, there are theoretically equations or analysis can be done to estimate the pressure losses, drag forces, and many other engineering parameters of interest. But there are many cases in which geometry is so complicated that theoretical analysis is not possible. And many times what happens, the equations derived based on our theoretical understanding are so complicated that it is very difficult to solve with the theoretical analysis. In such cases, generally research engineers and scientists turn to experimental methods. In experimental methods, we are dealing actually with the fluid flow, and many of the assumptions that we do in theoretical analysis are not there, and the results are the actual